Okay friends, today we will learn how to take a packet capture on a Palo Alto firewall. So the option of configuring the packet capture is under the monitor tab. You need to go to packet capture and you have some options here such as manage filters and stages. So you first need to configure filters so that only the interested traffic is captured. And there are certain stages which you need to add, such as receive stage, transmit stage, and drop stage, and capture the corresponding stage packets in the files like receive, transmit, and drop. So to explain this in a better way, I have a diagram set up here. So this is my trust PC, untrust PC, and the firewall Palo Alto. And the source address of the machine is 192.140.1.1 and the untrust PC IP is 192.150.1.1. The Palo Alto is doing a source NAT of this traffic to 192.150.1.2. So I have some arrows drawn up here. So let me explain you that. So let's say I am doing a ping from 141.1 to 151.1. In that case, the packet which is sent from the PC and is received by the Palo Alto, I am calling it as A. The same packet, when it is transmitted out by the firewall to the untrust, I am calling it as B. The reply from the PC to the firewall, I am calling it as C. The same reply when I am transmitting out from the firewall to the untrust machine, I am calling it as D. Now, these A, B, C, and D are captured in different stages. So the receive stage in the packet capture captures the packet A and C. As you can see, A and C are coming into the firewall. And the transmit stage captures the packet B and D. As you can see, B and D are going out from the firewall. So just to clarify, the packet A and B are the same. It's just that when it comes inside the firewall, I'm calling it as A. When it goes out, I'm calling it as B. The packets C and D are the same. When it comes inside, we are calling it as C. When it is going outside, we call it as D. Now, the filters which we configure need to capture all four of them. So we'll have to configure two filters. One filter will have source as 141.1 and destination as 151.1. This will capture the packet A, as A is going from 141.1 to 151.1. And it will also capture the packet D because it is coming from 151.1 and 141.1. The filters are bidirectional, so it captures traffic between that pair of IP addresses. Similarly, we'll need one more filter from 151.2 to 151.1 because the B packet, which is source natted now, will travel from 151.2 and go to 151.1, and C, which is the packet coming from 151.1 to 151.2. So we need two filters to capture A, B, C, and D. A and C will be put into the file which is configured for receive stage, and B and D will be put into the file which is configured for the transmit stage. So let's come to the firewall. I have this filter already set up here. 192.141.1, 192.151.1. This is a bidirectional filter, so it captures traffic from 141.1 to 151.1, also from 151.1 to 141.1. Similarly, we have another filter here to capture 192.151.1 traffic to 151.2 and from 151.2 to 151.1. Also, we have some other fields like source port, destination port, protocol, so that we can put a more granular filter. Since it's a ICMP traffic, I am not putting source port, destination port, as those will be random. I am putting protocol 1 because ICMP is protocol 1, and non-IP I am excluding it. ICMP is a IP based traffic, so I can exclude non-IP based traffic. Please make sure that you put a more granular filter so that you don't overload the CPU. So once you have the filters set up, you need to configure the stages. So I have 3 stages already set up here. So let me show you. When you need to click on add, and you need to click on let's say you're configuring the receive stage first, so you need to click on receive and give the file name here as rx maybe, and then click on OK. Similarly, you can configure the transmit stage, give some file name here, let's say tx, and similarly you can configure the drop stage, which is useful for troubleshooting if you suspect that the firewall is dropping some packets. So I have already set them up. So the rx, tx and drop file, and also I have already initiated the ping and captured the files here. So let me show you my trust PC here. So this is my trust PC here, and from the trust PC, sorry, this is my untrust PC. Let me open my trust PC. So this is my trust PC. From the trust PC, which is 141.1, I have done a ping to 151.1. Before initiating this ping, I need to turn the filtering and the capturing on. While turning on the capturing, it gives you a warning that this should be used only for troubleshooting and should be turned off when done. So you need to turn this on, and once you have turned this on, you can go to your trust PC and initiate a ping such as this. And once you do that, you will have the files formed up here. So I have a receive and transmit file here. I've already downloaded them. When you click on them, it gets downloaded to your machine. So I have already downloaded them. So I have this receive file here. Let me open up in Wireshark. So I have this receive file here. I'll go ahead and merge this with my transmit file. So I just go ahead and merge it with my transmit file. This way I can look at the complete communication in a structured manner. So as you can see, there are 2 packets, similar packets back to back. So I have a request, reply, request. So let's understand this. So this is the request packet which was received by the firewall, and this is the same request packet which was transmitted out by the firewall. So this is as per the diagram. If you go, this is the packet A. The first packet in the Wireshark is packet A. The second packet is B. The third packet in the Wireshark is C, and the fourth packet in the Wireshark is D. So this is my packet A, this is my packet B, this is my packet C, this is my packet D. Now how do you verify this? So let's have a look at the IP ID. So this is the first packet, the IP ID is 11522. For the second packet, the IP ID is the same. So both are same packets. If you look at the third packet, the IP ID is 27057, and for the fourth packet, the IP ID is same, 27057. So in this way, you can troubleshoot an issue on the firewall. So let's say you have the first packet, but you don't see the same packet in the second line. It means that the firewall received it, but it didn't transmit it. Similarly, if you have the third packet, means you received the reply, but you don't see a fourth packet, it means it received it, but it didn't send the reply back to the client. So such packets can be found at the drop stage of the firewall. So if you open the drop stage, you should be able to find those missing packets in the drop stage of the firewall. So I hope this was helpful, and thank you for listening. Thank you.